Scientific notation means a number is changed to be the product of a number greater than or equal to 1 and less than 10, multiplied by a power of 10. For example, 3,414,000,000 can be written as 3.414 times 10 to the 9th. Exploring lottery combinations and then probabilities can help students understand social justice issues using mathematics. A state lottery with 40 numbers has 40 times 39 times 38 times 37, 36, 35 possible ways in which the ball could come out of the hopper. But the order is not important, so we divide the different arrangements of 6 numbers, 6 times 5 times 4 times 3 times 2 times 1, which is 720, and divide, which equals 3,838,380 possible lottery numbers, about 4 million possibilities. They estimate the size of the universe is 4 billion light years. A light year is the number of miles traveled in 1 year. The speed of light is 186,281.7 miles per second. So in a day, it's 16,094,738,880 miles in a day. The human body is about 1 billion cells. The distance to the sun is 150 kilometers. The population of the world. Try to connect the large numbers to meaningful points of references. So distance from the Earth to the sun could be how many trips would it take to get to the Earth from the sun if you were driving from San Francisco, California to Washington, D.C., about 32,000 trips. Make sure to use real examples for very small numbers, just like with very large numbers. Connecting very small numbers to points of reference can help students capitalize on how tiny these numbers really are. The chance of winning the lottery. 26 divided by 100 billion. The length of DNA strand is 10 to the negative 7th meters. Every day, students interact with numbers less than 0, such as temperature, altitude, golf, money, timeline, and football, gain and losses of yards. Students need opportunities to make sense of situations new to them, such as subtracting more than they are, so 5 minus 8, and recognize that the sum generalizations they are constructed or being told. Since 5 is smaller than 8, and 5 is on when you subtract on top or vertical of minus 8, you end up having negative 3 as an answer. Minusing 8 from 5 is like adding a negative 8. 5 positive, take away from 8 negative, is 3 negatives left. With integers, students are often not sure which direction they are moving when they compute, so having a context in particular are important, so like a number line will be very helpful. Students need to understand that positive and negative numbers are used together to describe quantities having opposite directions or values, such as a number line, either vertical as a thermometer or a number line horizontal. Quantity contexts provide an opportunity for students to match opposites, so as 4, negative 4, 0 and 0, negative 1, positive 1, 1 million, negative 1 million. In golf, scores are often written in the relationship to a number considered a par for a course. So if a par for a course is 70, that's what an average golfer should get. That's breaking even, so they get a score of 0 if they scored 70. The golfer win. But if a golfer ends up with a 67, they would be 3 under what 70, so it would be negative 3 or 3 strokes under par. So if a person at a tournament had a plus 5 one day, negative 2, negative 3, and plus 1 different days, the final result would be positive 1, so 1 over par. And temperature. The number line measuring temperature is vertical. The context is demonstrating negative numbers may be most familiar to students because they have either experienced temperatures below 0 or know about the North Pole and South Pole. A good starting point activity for students is finding where various temperatures belong on thermometers. So temperatures in North Dakota would be 8 above 0, which would be above 0, -2, -12, and -8 would be below 0, and +4 would be above 0. Using counters and math is very helpful. Two color counters are a great fit for showing positive and negative numbers. One side, yellow, can represent positive and red can represent negative. The counter of each type results +1, -1 equals 0. Consider money. If yellow counters are credit, red counters are debits. Having 5 yellows and 7 reds is the same as having 2 reds or 2 debits, which represents -2. A number line is another way for visualizing modeling computation in negative numbers. One, it's familiar to students from their computations with whole numbers, fractions, and decimal. It's an excellent tool for representing operations conceptually. Shows distance from 0, allows students to explore non-integer negative and positive numbers. Connects to the coordinate axis, which involves 2 perpendicular lines. Arrows can be used in order for operations with negative numbers to show distance and direction. For example, 4 can be modeled with an arrow 4 units long, starting at a location on the number line and pointing to the right, and -3 modeling pointing to the left 3 units. Adding and subtraction. So, if you have -3 minus 5, a student might write, I was 3 feet underwater, then dove down 5 feet. Where am I now? I'm -8 feet. Contexts are an important place to begin. For students also need to be able to reason about the numbers themselves and draw their experiences and understandings of addition and subtractions. Rather than telling students the rules for solving, pose operation sentences involving negative numbers and asking students what they think my answer might be. 5 minus 11 equals n, -7 plus 12 equals n, -3 plus n equals 7. First, think about they are going down, and therefore the answer is -6. And the reason they start at -7 on a number line and go up 12 to 5. Good questions to ask. How do these two problems compare? How might you explain it to a younger student why you are changing the equation? Why, or how does knowing 5 plus 4 help you think of 5 plus a -4? I see that you counted up for this problem. Why did you count up? Addition and subtraction can be modeled with counters on the number line, as you see in this figure. Adding with counters utilizes the idea of adding opposites. Adding on a number line can also be involved by this idea, but can just move to a negative values on a number line. To add using the number line model, note that each added arrow begins with an arrowhead. And subtraction can be interpreted as a separate, take away, or compare the difference. An advantage to the number line is that it can be used for both separating and comparison situations. If you have -5 minus +2, such in the figure right on your screen, using a quantity model, the context could be money, such as I started with a $5 debit and then withdrew, take away $2 more from my account. What balance will my bank account show? To model this, you start with 5 right counters. To remove 2 positive counters from a set that has none, 2 neutral pairs, 1 positive, 1 negative, must be added so that 2 positive counters can be removed. Then 2 positive counters, yellow, can be taken away. The net effort is to have a $7 debit, -$7. A number line subtraction is illustrated with arrows separating. Use temperature as a context. The explanation could be the day begins at 5 degrees below 0. The temperature dropped 2 degrees, which means it's getting colder. It's now -7. And the figure above illustrates how students might draw arrows to represent addition and subtraction exercises. You can also have students write story situations as a third representation. It's important that students see that 3 plus negative 5 is the same as 3 minus 5. And 2 minus negative 6 is the same as 2 plus 6. Illustrating addition and subtraction problems on a number line and describing or discussing how these two expressions are related will help students see the connection between the expressions. Multiplication of integers is an extension of multiplication of a whole number, fractions, and decimal. Just like the addition and subtraction, students need the opportunities to apply their existing understanding of numbers and operations to consider how these structures apply to the negative numbers. The first example illustrates a positive first factor and a negative second factor, 3 times negative 4, which translates into the question, if you have 3 groups of negative 4, how much do I have? With the context options include, if I lost $4, 3 days, $4, 3 days in a row, how much have I lost? 3 days in a row, Hans scored negative 4 in a golf tournament. What is his score? 3 times today's temperature drop of 4 degrees. How much has the temperature changed? Connecting these concepts and looking at repeated examples can lead to students creating conjunctures about the rules of multiplying and dividing negative numbers. Connecting the division of negative numbers with what students know about multiplication recalls that division with whole numbers has 2 possible meanings. Two missing factors expressions. The equation 4 times something equals 24 asks 4 sets of what size groups equal 24, whereas the equation something times 6 equals 24, how many groups of 6 equal 24. The latter question, something times 6 equals 24, is the one that fits well with thinking about negative numbers because it leads to skip counting to 24. The first example on this page illustrates how 2 visual models, 2 color counters, and 2 number lines work for whole numbers. For example, in which the divisor is positive, but the dividend is negative. Understanding division with negative numbers resets on a good conceptual understanding of multiplication problems in which the first factor is negative and knowing of the relationship between multiplication and division.